Hey, my name is Andre, and in this video I'm going to show you how to use Chainlink Local, the Chainlink CCIP Local Simulator. Previously, with Chainlink CCIP, developers had to build on testnets, which means they will need to wait for 10 or more minutes to test a single cross-chain message. Now, with this tool, we can reduce this time significantly to less than a couple of seconds. So you can use Chainlink Local with both Foundry and Hardhat, both with or without forking the actual test networks. Here are the instructions how you can install it in both frameworks, and to use the Chainlink Local is as simple as importing CCIP Local Simulator or CCIP Local Simulator fork from the @chainlink /local package and just use it in your test or script. So let's see now how we can use Chainlink Local with Foundry on a local environment. So here I'll basically have like 4 examples, but for example number 1, we're going to use Foundry and local networks. Foundry and local network yet. I already created Foundry and Hardhat projects and installed Chainlink CCIP package. Now I'm going to show to you contracts that we are going to use. So we are going to have CCIP sender and CCIP receiver contract. Let's see, how can I just open it? Oh yeah, here it is. So if I just move it to, split right. So yeah, here are the CCIP sender and CCIP receiver. So extremely simple contract. So CCIP sender will send both tokens and some text like hello world. So here sending text, token amounts, we're going to send CCIP BNM. We're going to use a link to pay for fees. And this is just the rest is like a logic for sending the message. On the other side, we are going to just have like a text as a storage variable. And inside that text storage variable, we are going to store the string that we are going to receive from the other side. Now, going back to the GitHub, let's install the package using Foundry. So I'm going to just copy this command, go back to Visual Studio Code and install the package. So I'm going to paste. So inside the Foundry project, I'm going to paste this command and I'll just add no commit flag because I don't want to commit anything. Cool. And this is the process of installing the package locally. And once that's done, I'm going to just set the remappings as described in the GitHub as well. So if I go back to GitHub, I can see here that I will need to add this line to either remappings.txt or foundry.toml. I'm going to use foundry.toml. So back to Visual Studio Code, we can see that we successfully installed Chainlink Local. I'm just going to go to foundry.toml here, and yeah, we can put this aside and add this remapping like this. So now if I run forge build, this should work right. Okay, it compiles, nothing fancy. Now I'm gonna just reuse this counter.tsl, that test, to write my own test. So I'm gonna rename it to demo, and I'm going to rename this to 19, and I'm going to delete this. And if I go back to GitHub, I can see that I need to import CCIP Local Simulator like this. So import CCIP Local Simulator from Chainlink Local, etc. I'm going to just run forge build one more time to validate that I installed my remappings correctly. And yeah, everything's fine. So now I'm going to have CCIP Local Simulator public CCIP Local Simulator here, and inside a setup function I'm gonna initiate it actually. Also, if I want to use fork networks, I'll just import CCIP Local Simulator fork, but that's for another tutorial. Cool. Going back to GitHub, I'm just gonna copy the whole setup function because that's going to be easier. So this is something that we we saw on the README. This actually needs to be iRouter client, so I'll fix the README for that. So iRouter client, because that's the interface that will be used by developers actually. We'll also need to have wrapdth9, link token, and burn mint ERC77 helper, just to make sure that this will work. Okay, cool. I don't need anything from the faucet right now. Okay, cool. Now let's deploy our sender and receiver contracts. So what I'm gonna do now is that I'm gonna import CCIP sender unsafe from here. Yep. And I'm gonna do the same thing for the receiver. So import CCIP receiver unsafe. Here it is. Fix this, fix this, fix this. And I'll also just set up a test for these two contracts. So CCIP sender is going to be sender, and CCIP receiver, it's going to be CCIP receiver. Public receiver. Okay, cool. Inside my setup, what I need to do is I need to deploy these two contracts. Now, if I put this aside once again, so split right. Yeah. Here I can see that in my constructor I need to pass link and router addresses. So that'll mean sender equals new CCIP sender unsafe, so address of a link token, so that'll be address of a link token and address of a source router. So when I did this line, CCIP local simulator equals new CCIP local simulator, CCIP local simulator under the hood pre-deployed all the necessary contracts, mock contracts in a local Foundry or Anvil environment, and now I'm just gonna interact with all of these contracts, and with this configuration view function I can expose all of these contracts. So from source router, link token, which I'm gonna use for fees, CCIP BNF, which is the token I'm gonna send, chain selector, and more. Then I'm gonna do the same thing for CCIP receiver. So CCIP receiver, we're gonna just move it on the other side as well. Just move it here, and we can see here that I just need to provide the address of a router. So receiver, it's gonna be new CCIP receiver unsafe, and then address of the destination router. Now let's do something meaningful in a test as well. So first of all, we're gonna test the send function. So if we take a look at the CCIP sender, it kind of assumes that it have the token we're gonna send, and also it has the link we're gonna send in it. That means that even in a setup, what I can do is I can use CCIP Local Simulator to request link from faucet. I'm gonna actually send it to sender, and here I can do something like this. So uint amount link for fees, actually it's gonna be, let's say we want 5 link, so 5 ether and link for fees. So I'm requesting 5 link to be transferred to my sender contract. Okay, cool. And what else I can do is that I can use CCIP BNM drip function, which will send to address sender exactly 1 CCIP BNM. And I'm just gonna quickly run forge build to make sure that this compiles. Okay, cool. I have a couple of unused variables, but that's okay. So I'm gonna just write first test. So what we need to do is here, before sending the message, we need to have link in our contract, we need to have CCIP BNM in our contract, which we have, and now I just need to call the send function. So that'll be sender.send, and and I'm sending to address of receiver contract. So we'll string memory some text will be hello world, for example, and amount, so uint256 amount to send can be 100 CCP BNM. So here it's going to be some text, then destination chain selector is actually chain selector from here. So what I'm going to do is I'm going to do something like this. So uint64 is, let's say, destination chain selector. Always the same thing. So this is one local network, and destination chain selector is actually chain selector from here. And I also can use, let's say, CCIP BNM token, and I'm gonna just do something like this so I can reuse it in my test. So some text I'm sending, destination chain selector is destination chain selector, token I'm sending is address CCIP BNM token, and amount I'm sending is amount to send. And this is it. Now what I need to do is again run forge build just to make sure that everything's works. Okay, cool. And I need to run forge test --v. Okay, cool. Now we have the receiver error and something's wrong. So we can see that when we called send, the CCP send function got called, and then on the CCP receiver side, something failed. And we can see, okay, this is the receiver error, and this is the function selector of a receiver of the error, and this is some address, right? And here, so what I did is I intentionally make a bug. So I can show you that now in less than a second, I noticed the error instead of like waiting for 10 plus minutes. And if I go to CCIP received, I can see that there is like a modifier, only allow listed sender. That means that first I need to call allow list sender from the owner address, which is the address that deploy the contract. So I need to allow list the sender contract to send me messages to prevent this error from happening. So what I'm going to do here is first receiver allow list sender, and we can do address of sender true, and this should work. So if I do forge test once again, now I should not see errors. Cool, test passed, but we didn't do anything right. So we just validate that this works in a local environment. What I can do is I can first log the message ID. So this is the CCP message ID. Message IDs we use there'll be console log bytes 32, I think. We use to, or console log, let's see, is this gonna work? Or maybe like this. This message ID is the message ID we use on ccp.chain.link on CCP Explorer to track messages. And we can see, okay, this looks like a legit CCP message ID. But what else? Well, actually, we need to see the text. So that'll validate the text we received. So what I can do is I can say something like this. So string memory received text equals to receiver dot text, and I can now console log received text to validate that everything is fine. So if I do that, I can see, oh, here it is, local hello world. That's great. What I actually need to do is I need to use assert equal receive text to be the same as some text, the text I sent. So that'll be actually be a much better test. So I can do now forge test, and this should not revert. The second thing that I need to check is the address of CCIP BNM. So I can do something like this. So uint256 amount before, so sender amount before equals to CCP BNM balance of CCP BNM token, balance of address sender. And I can do the same thing for receiver, right? So there'll be receiver amount before, we can do receiver here, and also I'm gonna do the same thing after the transfer. So here there'll be after, and for now I'm just gonna console log all of these. So there'll be sender amount before, there'll be receiver receiver, here it is, and I'm gonna do the same thing for after, just to see that everything's okay. And essentially what we want is to assert all of this. So once again, forge test www. Okay, cool. So we started with 1 CCP BNM on sender side, 0 on the receiver side, and then add up with 9999, whatever, less than 1 CCP BNM token for sender side and 100 units of tokens on the receiver side. So our test should be actually that assert equal that sender amount before minus sender amount after should be the amount we sent, and vice versa on the receiver side. So receiver amount after minus receiver amount before should be this amount we sent. Okay, cool. Let's see, did I did that correctly? So once again, forge test, and yeah, there it is. So that was it. That was the example of how you can use Chainlink Local with Foundry on a local network. This is the first example. If you want to see more examples, then check out the next video. Thank you.